to
Hey, Cliff.
IoTeaLive. So interestingly, Paul DiCarlo has come through on Cliff's screen share there. So Paul, you are Cliff for some reason. Not quite sure how that's happened. Interestingly. Oh no, there we are. If I move Cliff out of the way there, look, Cliff screen share.
See, got my.
Yeah, that's all right. I've just put you over the top of me. No one wants to see me anyway. I'll delete that. Look. Yeah, that can go away. So yeah, thank you very much for coming along today. We are just at the start of the first of a few NVidia Jetson AI ML at the Edge workshops, where specifically Cliff and Paul are going to be working through some material that Paul has created in the past, along with NVIDIA, to help people to get into AI and ML using the NVIDIA Jetson. Now, last time we ran workshops like this, it was me and Benjamin Carbe sort of doing the driving. But this time it's going to be all Cliff. And in fact, Cliff is over in a hotel room in Seattle. So not only are we going to be getting Cliff up to speed with NVIDIA, but also with hotel Wi-Fi. So there will be some.
No, we're not using hotel Wi-Fi. Well, we are using hotel Wi-Fi, but we're using my phone as the router to connect my laptop to my Jetson, and then a little mini keyboard that I bought from Amazon to connect to it. I'm using the HDMI connector cable thingy bob to make it all work. So yeah, yeah, this is strung together. I took the hotel TV apart earlier and got it all connected up to that to get it all working, but I don't need that now. So.
I mean, that's dedication, though, right? Like you've clearly thought this out. How can I do this from wherever I'll be on Thursday?
Yeah,
which happens to be
Seattle.
Yeah,
very exactly so. Now, obviously, there's quite a few moving parts with this that could go wrong. Cliff has got one of these little HDMI capture card type devices, quite cheap things that we managed to get when they're on offer a while back, that he's got plugged into his NVIDIA Jetson, and that is plugged in as a video source, of course, then into his Surface Book, and that is being shared over OBS Ninja as a camera. So the quality of that stream will never be amazing. So if you see anything on there that you can't read or it's blurry and we need to zoom in, then just stick that in the chat, and I'll keep monitoring that, because I'm sort of just the man pressing buttons and chatting today, so I'll be in charge of that. But I mean, onwards from that, Paul, did you want to just give a brief explanation about what it is that we're going to be doing, at least this week and next week?
Yeah, so what we want to do today is sort of explore what is the Deep Stream framework, which is a intelligent video application pipeline service or framework, I guess to say the word again, that allows you to very easily string together sources of videos that can be processed in a accelerated fashion, meaning that frames are gathered utilizing CUDA and GPU acceleration capabilities on the Jetson device in question, and then being able to apply various different object detection algorithms and those sorts of things. And we'll sort of go through what I'm really hoping we can cover today is really just an introduction to like what a deep stream configuration file is composed of, and then hopefully being able to modify that so that we can create a custom application. Now, if we're successful with that goal today, that will put us on a really good path for next Thursday to be able to look at how can we take our custom configuration and deploy it down as, say, perhaps an IoT Edge module. So combining the powers of Azure to go from having a working application that can do some multi-video processing and inference at the same time, to being able to, say, connect that with cloud services, being able to do things like push telemetry up into the cloud, visualize that data, also even orchestrating your deep stream workload in general to be able to work with those facets and features. So it's quite a bit that we'll be doing, but I think it's certainly doable. And I want to approach this too. I know Cliff is new to this, and probably many of the viewers out there don't have a background here. So the whole idea is really to approach this from a starting from zero standpoint. So you should see us encounter the same types of problems you would probably encounter if you were to embark on this on your own, except with the added difficulty of we'll be working with hotel Wi-Fi today.
And very
It'll
remote
work. Have
as well.
faith.
It will. That's the whole point. If you came along to the previous version of this, this is supposed to be unrehearsed essentially. So, and I know obviously Paul, he knows content inside out, but Cliff, this will be essentially your first time looking at this content and working with the Jetson,
yes.
although you've had it a while. So, exactly as Paul says, this is supposed to be very real life, so that we give the same sort of feel that you would have if you were going to run through it yourself. And so we can go through the same sorts of learning. So if you're coming here to watch a talk on the NVIDIA Jetson, then that's not what we're going to be doing this time. This is literally walking through some content and experiencing it as though you would be doing yourself. So it should be really interesting. And thanks very much to Paul and to Cliff for going to the effort to making this happen as well. So welcome to the journey.
Awesome. So probably the first thing that's worth covering is like, what is the device we're messing with? And Cliff, I don't know if you have yours on some sort of feed, but I can hold one up just to hopefully give people an idea.
No, I got it here. I got it here. Oh, hold on.
Oh yeah, we haven't got a bigger version of it there, but that's fine.
So, and just to point out what these are in a nutshell, like if you want to think about it, it's kind of like a Raspberry Pi on steroids. The steroid part being that it has a GPU, and this makes it a lot more capable in terms of running AI types of workloads and things like that, CUDA accelerated processes and things. What's interesting too is that this particular device, at least the one I'm holding, this is a 4 gigabyte model of what they call the Jetson Nano. What Cliff was holding up looked like the 2 gigabyte. And you'll notice there's just some slight differences there in that his would use like a USB-C cable for power instead of the typical micro USB you see here, and just a little bit of smaller RAM. But what's interesting there, speaking in US dollars, the 4 gig model is usually around $9,900, depending on where you shop it at, and the 2 gig is around $60. So it's actually a really affordable device to break into these types of things. So I'm sure many of you are aware it's the other way to do this is, of course, buy a nice graphics card for your PC, but sometimes those aren't as easy to get a hold of at the moment.
Good luck.
But if you are looking for like something, and that's the other takeaway here too, is that you got to look at this form factor. If I hold this up to my phone, there's really not that much size being taken up by this device. It can be employed in a lot of different use cases and areas to perform what we'll be doing today, which is live video analytics and that sort of thing in a just small form factor. I believe consuming maybe 10 total watts of power at max draw. So very, very green, efficient way of running your workloads on a local device. So I think before we get started here, Cliff, I see that you've actually got your device connected and we can sort of see the OS that it's booted into. That'd be a good place to start exploring.
There we go.
And so you'll see there the green screen that Cliff is showing here. This is what you would normally get. I'm sorry?
I think Pete needs to switch it on the feed for. I'm not sure if it's coming out on Twitch yet.
I've done it. Yeah, no, I've pressed it. So it should be there.
There you go.
Yeah,
okay.
Just make sure we're following the same thing. Cool. So this is like the traditional desktop experience, if you will, that you get out the box when you boot one of these devices up with the NVIDIA provided operating system. So that is called Jetpack. I believe the current version is 4.5. And this is it's an Ubuntu based Linux distro, but what's kind of cool about it is it actually ships with all of the libraries typically that you would use for accelerated inferencing. For example, things like TensorRT, the CUDA Deep Neural Network, CUDA Toolkit, various accelerated multimedia APIs for doing things like grabbing frames and video for Linux device feeds insanely fast, and computer vision tools, for example, things like VisionWorks, OpenCV, and a number of different developer tools that can help you basically perform, developer tasks. So there's things like an IDE that actually gets included there, and other things. So you sort of get this just out the box, like ready to rock and roll. But don't think that this is just like someone grabbed Ubuntu and slapped like an NVIDIA logo on it. There are some custom libraries here that are also brought into this OS that are going to really help us take advantage of certain features and functionalities as we move along. So any questions in the chat here just about what Jetpack is before we sort of move on? Cool. And
No.
Pete and Cliff, I don't know if you guys wanted to provide just any quick background on what it takes to get that installed on one of these devices, just in case folks are wondering.
Well, I can talk to what I did was I went to the NVIDIA Jetson website, downloaded the ISO and followed those instructions. Use Bellino Etcher to burn the ISO onto the SD card. The gotcha you've got is the fact that it says it sort of buried in the text somewhere that you need to have a minimum of 32 gig cards. And then it says that, a lot of things won't work on that, and it recommends an absolute minimum of 64 gig. So I bought 128 just to be certain, because it weirdly on Amazon it was cheaper than the 64 gig. So I think it cost me about £18 for an micro SD card. I use Bellino Etcher, which is an awesome tool. I use that for my Raspberry Pi images and stuff anyway. So I had that installed, copied the image across the SD card, plugged it into the bottom of the Nano, powered the Nano, and just went through. There's like you connect to it using PuTTY, which is like a COM-based text-based interface, and I went through and set it all up using all the it's like a text-based, like DOS-esque kind of setup, which you go through and tell it which Wi-Fi connection and stuff. So at the moment it's connected to my phone, it was painless. That was the easy bit. And then for the video, so that everyone can see on the screen the video, I've got the HDMI cable coming up and connected to HDMI capture, which is coming in, and then that's streaming to OBS Ninja, and all seems to be working. Fingers crossed. And then I've got just a little mini keyboard that I've got on Amazon as well, which is my little tablet keyboard for when I'm playing with Raspberry Pis and stuff.
I was going to say, too, for folks who really want to see your setup, like what it literally looks like right now, Cliff is on Twitter at Clifford Agius, Agius, Clifford.
Agius, yeah.
Yep. And definitely recommend checking out what that setup looks like. I'll go ahead and paste that over to Pete, who can maybe share that out in the channel. So you can sort of see the most important thing, I think, that you've got going on, and really anybody else who's out there, is these devices, they ship with a heatsink, but they do not ship with any form of active cooling. So you'll notice that in the picture, Cliff has a desk fan that's essentially pointed at the device, which is kind of important, as you'll see, because we're putting this thing to work here shortly. And if you don't have some active cooling, that could actually create some sort of, not a full meltdown, but perhaps some system instability and things like that. If you
that fan was an emergency purchase, because I left the one that I intended to bring, which is a USB fan, on my bench at home. So I arrived into Seattle last night at 1 a.m. UK time, and made a quick trip down to Target, or Target as it's called. Anyone that's from the UK remembers Mrs. Bucket. But yeah, we rushed down to Target and made an emergency purchase last night, and it seems to be working. It's quite good. So.
And just for folks out there too, if you look around, even on Amazon, etc., there is there's a lot of active cooling cases you can buy. Some of them are really cheap too, like in the sub $10, $15 range, that can get you going as well. So what we'll go ahead and do next here, Cliff, I assume that your device is connected to the internet. Let's see if we can't open up a browser. And one of the first things you'll notice is, for a 2 gig kind of small device, you'll notice that it's pretty darn snappy for an embedded, single board computer, as you can see there. And what we'll go ahead and do, if you do a search for NVIDIA DeepStream SDK, we'll go ahead and tour that offering from NVIDIA, give some background on it, and hopefully work here in just a few moments to get it installed. And I sort of alluded to this earlier. It would be that first link there, Cliff. The DeepStream SDK is really a sort of all-in-one, and as you'll see, really simplifies the development of these live video types of applications or intelligent video applications. How it works underneath the hood, it is actually sits on top of a framework called GStreamer, which is used for a lot of multimedia streaming frameworks. So you've possibly used this in the past, even if you're using a Raspberry Pi, maybe you want to like play back MP4s and things like that. The added benefit of what DeepStream does is it has a number of different plugins that sit on top of GStreamer that have been specifically optimized for the libraries, the acceleration libraries that I mentioned that are included in Jetpack SDK, so that you can get accelerated processing on some of the normal features of GStreamer in addition to some of the advanced features. So for example, just grabbing frames, you can do that now in an accelerated fashion. And hopefully we'll get to see that today, but I believe that the Jetson Nano devices are fully capable of simultaneously processing 8 video streams, 8 MP4 video streams at the same time. And again, that is a full function of being able to do this using acceleration. And the other thing to look at is that we have the ability to run inferencing or AI processing. So doing things like object detection algorithms on those frames as they arrive in real time or near real time, depending on how you look at it. So one other thing I may have glossed, this is not the only device that NVIDIA makes in their embedded line. There is a whole host of devices that range from the Nano to something they call the TX1, the TX2, which are increasing in power. And then at the far end of the spectrum is something called the Jetson AGX Xavier and the Jetson Xavier NX, which are kind of, the last two are sort of almost on par with each other power-wise. The AGX has some slight additional enhancements, but the far end, and just to give you some example of like what you could see there, those can process 32 simultaneous video streams. So you get like 4 times the power, and it's about 4 times the price to achieve that, around the $400 range.
It's still quite cheap.
Yeah, overall, I mean, especially when you think about like what you're getting a full computer, and it actually does, the higher end ones have active cooling on the actual dev kit itself. And as snappy as your device is, Cliff, like using one of those feels like you're sitting at a full powered desktop, but it's kind of funny because it's actually just a device that's, this big. So
yeah,
it's cool. So looking at the DeepStream SDK, I see you have that brought up on your screen there. They give you sort of a good rundown of this graphically in the image, sort of scroll down there like what this thing really does. I know I mentioned a good bit about it, but the whole idea here is to facilitate rapid development of intelligent video applications. So as you can sort of see, where whether you're taking in camera feeds from various different entities like safety, retail, construction, you could perform that inference on site. The benefit of that being that you don't send camera feed data to some cloud provider or something like that, you're not processing. Because of that, you get results in the moment. You can act on them in the moment, and you can build a lot more mission critical types of solutions. But what gets really cool is that you might want to be storing off some of that data either for archival purposes, or maybe you want to be showing live operators what's actually going down at the factory floor. There is plugins there that will get you to the cloud if you do want to push that telemetry. As you'll see down here, if you kind of scroll a little bit further, it will show you some numbers around the performance for various different object tasks and those sorts of things. So you'll see here, they give you a nice table. And I'll go ahead and, just in case folks want to follow along, I'll send this link over to Pete, who should be able to, the folks in the chat. So we'll go ahead and send that link over. Pete should get that out to y'all in just a moment. And if you notice here, like as you're sort of looking in that table, we're of course working with the Jetson Nano device, and it's kind of giving you some example applications, telling you like what kind of performance would you expect here. So people detection using ResNet 34 with a 960 by 544 int8 precision gets around 11 frames per second on the Jetson Nano. But this gets, as you sort of like go down that same column, you'll notice that, well, we could do face detect with a precision of int8 with 96% accuracy with 101 frames per second. Again, face detection being a little bit, at least in the way that this is implemented, and the inference resolution being smaller, does free up a bit more of the cycles so that that can be processed faster. Some of the examples we'll see today will mostly be hitting 30 frames per second. So these are, I'm not entirely sure which applications these are pointed at, but we'll probably find them in the samples directory. But the thing to keep in mind, I'd alluded to there being various different models out there. You'll see here that like almost as soon as you get past the Jetson TX2, it doesn't really matter what you throw at it, you'll start to get beyond 30 frames per second performance. And you could sort of think about that. If I was to divide that by 30, that would sort of tell you, how many different feeds you could process simultaneously, more or less. And you'll just notice that that number goes up considerably. You may be wondering too, for the Jetson Xavier NX and AGX, it actually gives you multiple measures. It says GPU frames per second, and then something called the DLA1 and DLA2. The DLA refers to something called a deep learning accelerator that is an additional piece of hardware on those models that does not exist on Nano. And so it is capable of running its own special forms of inference and that sort of thing, depending on what sort of workload you throw at it. So kind of a bit of overview here do is go ahead and look at, well, where can we go ahead and start getting our hands dirty? Because while I've described this, I feel like the best way to truly do this is to actually download and install the DeepStream SDK. So you should see here on the same page that you're at, Cliff, if you scroll all the way up to the top, there's a link getting started. And that should bring us to the getting started documentation around this particular offering. So it should be, if you scroll all the way back up to the top there.
There you
go. We'll go ahead and click there. Now, I mean, we can live dangerously if you want. I see here that there is a preview of the DeepStream SDK 6.0. I'll be honest, I've not touched it.
Why not?
I hope it works the same as everything we're familiar with. So we can do that one. The only thing is, it looks like you're going to have to sign up for some additional, I guess, preview access there, which we're happy to hang around while we do that. Or if we want to just go the supported route, we can look at the DeepStream SDK 5.1. Either or. We'll let you decide.
Get partway through. So I can hear myself in many places for some reason.
Yeah.
Not sure why that is. Oh. Hold on. Can you still hear me, by the way, you pair?
Yeah,
Yeah,
in about 20 places.
Yeah, I don't know why that is. Oh.
I think what Pete was going to say, Paul, was the fact that it'd be a shame to go to the new version 6 of the SDK, get partway through and find out it's completely changed it, because it's a major version bump. So there could be some big breaking changes that we're not aware of since we've just seen it. So it might be better to stick with 5.1 that you know, and then maybe look at the 6 a bit later.
Yeah. I think that's a good, healthy way to look at it. Maybe we could do like a why not both if we have time.
Yeah.
So yeah. Let's go with the 5.1. I like that, especially pointing out that it is a major version change. So the download isn't too hard to do. Once you scroll down there, there's like an I agree box, and once you click that, you'll notice that the download links magically appear at this point. And what we want to get, the easiest way to do this will be to download the Debian package for that is targeted for Jetson. So the that one particular one. If you go ahead and click that, it should actually be pretty straightforward. Now you're going to need an NVIDIA developer membership required here, which if you don't have one, it's super easy to set up. So if any folks that are following along here, literally just requires the entering of an email address and determining what you want your password to be, more or less.
Okay, 1 second, I'll do that in NVIDIA.com.
And if we get to some point where we need to not share the screen, we can do that, but I think it's going to be rather occluded once we get there.
Oh. So I need to.
And keep in mind, Cliff is typing on one of the world's smallest keyboards.
When you travel, you find things that work.
And the good news too, Cliff, like I don't think that's going to be too much of a. I don't think it's going to affect us much at all, as long as your up, down arrow keys and tab skills autocomplete will get us through the day.
I don't know if my audio's any better.
Seems to be.
Oh, that's all right. Yeah, I managed to fiddle with things.
There you go.
So feel free to send Cliff your pictures of cats and things like that.
Do you want to pop my thing off the stream there, Pete, and I can enter a password?
Yep. Done.
It's saying sign in. Don't have an account.
Oh, you're trying to sign in rather than register.
Have you created an account?
No, I thought that's what he was doing, but it's not done.
Oh yeah. It's kind of a, for those that can't see what's going on. When you do select to sign up for an account, it actually brings you to like a login screen, and then there's a smaller actually create your account button. Typical, yes.
Someone's already got my display name. How can someone have that?
How very rude.
Limited on the end. Always works.
That is curious. We'll have to find who that user is.
Yeah. Send them a naughty message.
To be fair, though, CA Software, I mean, that could be a software developed in Canada, California.
Could be anywhere in the world. Could be anywhere in the world.
The island of Curacao, yeah.
I'm a human, but I could be a robot. Oh, man. What do you want me to find? It's
Oh, these are. It's now giving him an NVIDIA level of difficulty.
Yeah.
Find the angry
trains.
people.
That one's a train. That one's a train. I think
this one might be a good one to share to the audience. So, who thinks these are trains?
Yeah.
We'll take your sampling and go from there.
I'm not sure that middle one's a train. I think it is actually. That middle one looks like, because you can see it's a tricky one. That is, because you can see the other power lines. So I'm going to tick that as a train as well.
But this is
harder.
This is a solved problem, though, isn't it? Capture's been solved by machines already.
No, but what they he wants to know my date of birth, which I never tell the truth on anyway.
Oh, well, you're off screen again now, anyway.
All right. Let's give it a. The thing is that a lot of that is Google trying to teach its cars how to. There you go, 1969, that'll do. Is Google trying to? I'm not that old, by the way. I may look it.
You're gonna feel that old after this.
Yeah. It's Google teaching its car, its in-car like kind of AI for doing the automated driving. So it's what they've been using. Do you remember, like a few years back, they had this project where they was digitizing all the books in the world.
Yeah,
so they were showing us words that we had to type in. And the reason we had to type 2 words in was, one was they knew the answer to that one. That was the real capture to check you wasn't a robot. And the other one was can you help us kind of work out what this word is, because our computer can't read it.
That's right.
So now they've got self-driving cars. They want us to tell them where a pedestrian crossing is, where a cyclist is, where a train is, that sort of thing. And it's because they're teaching their cars. So
looks like you are awaiting an email.
It's waiting for Outlook to open.
Gotcha.
I'm assuming I can share your screen at the moment, Cliff. It's nothing.
Yeah, I think that's safe. So we're just waiting on a registration validation, essentially, to go through here.
Yeah. Come on, you can do it.
Hotel Wi-Fi. You see, you're screwing the whole hotel Wi-Fi with the various things that you're hanging off of it now.
Yeah.
Someone's trying to watch iPlayer or something on the next room, and Netflix or whatever.
And I promise y'all, this is like the hardest part of everything we'll do today. It's like,
there you go.
Can you create the account? There we go.
Yep. Aside from Cliff trying to type on his tiny keyboard, that's probably the hardest thing. But
yeah. You've gone all echoey on us again, Pete.
I don't know why that is. I don't know if maybe my sound is coming back through Paul's speakers. That's the only place I can imagine, because I've actually turned the sound off there, but I can hear an echo.
Yeah, I've only got one tab with the sound on. All the others are silenced.
Hey, let me mute my speaker and start talking.
Can I hear an echo? Oh, it's even worse.
Interesting. It was really clear for me over here when I.
It was actually worse at that point.
Wow.
Now I can hear myself again. That was odd.
You haven't got Twitch open or something, have you?
No.
Yeah, I have my speaker muted on both shares, if that means anything. And if I unmute, apparently your audio gets better. That's weird.
Don't understand that. Hang on a minute. I don't know. Yeah, no.
And it's also that Cliff doesn't have this issue.
Yeah, I've got the echo, but yeah.
Yeah, but I guess we don't hear one from you. But yeah, it does seem like there's something here when I mute my speaker. It certainly affects things. Well,
very odd. Very odd. Yeah, it's coming for if I mute you in OBS Ninja, then my echo disappears. So it's definitely something from your webcam feed that you've got there is playing me back. Can I still hear you, by the way?